This video shows the automation of two bespoke multiplex panels that have been developed in-house to measure 8 novel biomarkers simultaneously for the EMPA-Kidney clinical trial. These plate-based methods have been automated using a Biomec i7 liquid handling system, enabling 108 samples to be tested in a run. Typically a run would take 5 hours. I'm going to talk you through it in 3 minutes. All the labware needed for sample analysis is stored in these towers and is automatically fed into the liquid handling system. First, labware for sample preparation is loaded onto the deck. The volume of each sample is then measured to facilitate accurate pipetting. Samples are sub-aliquoted into a specific layout, which enables them to be tested on 2 different panels at the same time. This streamlines the process and means samples only undergo one freeze-thaw cycle. Samples need to be diluted before analysis. This takes seconds on the liquid handling system and is carried out with incredible consistency. Performing this manually would take hours, and it is easy for mistakes to occur. Samples are then transferred in duplicate onto the reaction plate. This plate has 96 wells, each coated with antibodies that bind to the specific biomarkers in the samples. Standards are added so the concentration of the biomarkers in the samples can be calculated. Quality control samples are also added so the performance of each assay can be closely monitored. The plate is then placed in an incubator for an hour and a half. Once the incubation is complete, the plate is transferred to a plate washer. Each well is washed 3 times, leaving the specific biomarkers bound to the antibodies coated onto the wells. Detection antibodies are then added to each well that bind to the captured biomarkers. These antibodies have electrochemiluminescent labels attached to them that allow for ultra-sensitive detection. The plate is then placed in the incubator for an hour. Once incubation is complete, the plate is washed again. The final step of the method is the addition of a buffer that allows an electrochemiluminescent signal to be generated. The plate is then transferred onto an instrument which detects the light produced from the electrochemiluminescent labels when electricity is applied. The intensity of the light produced is used to quantify the biomarkers in the samples.